just I'm so this will be available for your reference after the masterclass also. So you can take the reference from the videos that would be there. So we had talked about in our previous of masterclass related to the difference of the embedded security, device security. So if I just recall, we have started with the IoT security overview. Then we had talked about the application level securities, the transport layer of securities, then the physical layer of securities, the hardware security elements we had talked about in our previous of the series. Thereafter, we had talked about the related to the industrial IoT security and for the applications. Then we had moved to implementation side. So there are the concerns. So once we talk about the security, so there are the two aspects of it. First, what are the concerns? Where are your security holes? And then how do we mitigate it? So from the past of the masterclass, we are now in the mitigation phase, and that started with the cryptography and how to implement. So in that, we had talked about the device securities, and thereafter, the three key elements of the IoT security, which relates to the confidentiality of your information, the integrity of the people, and how do you authenticate it, like whoever wants to join to your ecosystem, your IoT ecosystem. So how do you authenticate and authorize him? So there are the different means for that. And the one of the standard meaning and which is established one is the PKI methods, the secret key cryptography and the asymmetric cryptography that relates to the public key. Then we have the algorithms, which is the Diffie-Hellman algorithms, and thereafter the ECDSA algorithms. So these are the difference of the algorithms, and the session key establishments features are there. So we had talked about all of these features and the how do we deal with it, how the algorithms are there in our previous of the session. And all of these sessions related to this master classes, which has happened previously, you can access it on this link. You have been given through email also this link. I just share you the link again, and you can just be the part of here, and you can access all of the materials seamlessly from this location. And apart from that, the discussions like, so we have this social discussion page, so you can go through. So here everything is uploaded, you can see, and I keep updating about the new happenings also here. So this is it. So like that, we had talked about the sessions. So these are the updated over here. So if you have the queries also, you can put. So you have to join this community, and I'm sharing you the link just in your chat window. If you have not done yet, so you just do it, so that we all will be on the same platform, and it would be easy for you to cope up. So this is the link which I have just shared you in your chat window. You need to join it. So you can access this our social LMS. So this is our social LMS. So so here you can access all the contents, and you can access seamlessly through your browser. So you can open it and make the joining through the browser window, and thereafter you can download the app also. So if you go to your Play Store and just Edmodo. So on your Play Store, this app will come, and you can install this app, and with the login ID and password which you are using just for the account creation, you can just log in through that app also. And then through this, you can access it on your mobile. The app is available for the Android and the Apples both. So you will join it, and then you can access all the contents, previous contents also, if you have not attended, and the future of it. And it would be easy for you to put your queries and the guidances if you need. If you're working on some of the IoT security projects, you need our guidances, so you can also post over there. So that's what is. So that was the just update from our side. And so we are moving now towards in this session further about the crypto element. So how many of you have heard about the crypto element before, or any idea of crypto element? What I'm going to talk about? What is a crypto element? Anyone can give me any idea that what crypto element is? What I'm going to talk about? No one? Anyone would, if anyone would like to answer, he can just unmute himself and talk to me. No? Okay. Just a simple question. How many of you have started designing IoT projects now? Okay, one answer is coded form of data communication. Okay. So, okay, we will talk about it. Okay, how many of you have started designing the IoT projects now? Like previous sessions, I have started talking and you were on the beginners phase. Now I just want to know that how much the improvement have come. Have you designed any IoT security projects yet? How many of you have attended our previous masterclass also? Just be communicative, either yes or no. I'm not going to give the marks over here. It is not related to any certification. Just let the session remain interactive so that I can also deliver you more better. How many of you have attended our previous masterclass also? No one? Okay, Darshan, this is your first. Okay. And shall I assume that others have attended previously also? Okay, Tushar, you have attended. Good. Any IoT security projects you have started working with? Or any IoT project? Okay, leave it. Just a plain question from you. Why do you feel that security is important? This is a general question I'm asking. Whether you have attended the sessions or not, why do you feel the security is important? Why you are investing your 90 minutes with me? Okay, so one answer is good. In order to maintain the privacy of data, and that's why you implement the security. Thank you. So one thing, it comes the privacy. And anything else? Any other things? Okay, no answers. It doesn't feel good. Actually, it seems that it is going to be waste the time then. If you are not getting motivated or not getting benefited. Okay, let me move forward. So see, the thing is that until and unless, why I was asking you, because until and unless you are not working on IoT, there is a no meaning of talking about the IoT security. So what I suggest you that start dealing with smaller, even smaller of the IoT projects, and then see that what are the vulnerabilities your project have. What are the points where one can attack you, one can attack your the product or the project which you are developing, and then the security is thought from that point. So we have the complete of the auditing mechanisms, and if you go to our previous of the sessions, I have discussed about the IoT security auditing mechanisms. How do we rate the, how do we give the points for the different of the IoT security vulnerabilities, and then we plan about the security. So it is not just a concept, or it is not just about a technology. It is a overall planning. Security is overall a planning, and that starts from the time when you start thinking about your project. The coming of the project on the ground is a way later. Once you start thinking, since then the security thing starts getting implemented, and it life cycle. So this is the crypto element which I'm going to talk about is based on the hardware thing also. So definitely we will be looking at that how this crypto element is incorporated into your IoT security life cycle, and how these things, how these keys and everything are designed, how these keys are generated actually, and fed into your hardware with the help of this crypto element, so that we can implement the security concerns related to our IoT project. So so if you have not seen me before, so just my introduction. So I'm Ahmed Chaudhary, and I head the technology and training division of Pragyatika. I have been in this domain for the last 15 of years, and I'm having Microchip masters, and I'm a training consultant with MSME also. And I have the complete of experiences on the microcontrollers, on the 8-bit, 32-bit, and everyone. And the organizations where I have worked with previously is IIT Delhi, DRDO, NIC, IBM, all these places I have worked on the IoT, robotics, and the electric vehicles is also one of my core domain where I work with. So these are the some of the technologies and the skills that I possess. And in this role of technology and training division of a Pragyatika, I completely take the responsibility of delivering the new technologies to the industries and the academia both. So as a at Pragyatika, we have the services for the enterprises and institutions, and we provide the consultancy, training, and R&D. We have the in-house R&D where we take the projects from the various of industries, and our new product development wing is also there. We are having the authorizations with the top of semiconductor companies like Microchip, ST, and Renaissance, where we are delivering their projects for their clients. And we have the support for the academia also. So this is a training division, the Pragyatika. This is the training division of us, where we deal with the academia, and we are bridging the gap between the academia and the industry. So this is just a small introduction of who we are and what we do. Now coming back to the topic. So we deal into the embedded systems domain, the IoT domain, embedded AI domain, EV domain, and the automotive electronics and industrial of electronics. And lots of students are getting trained and getting interned through us also. So today we are going to talk about the IoT solutions, that how do we build the IoT solutions, what are the concerns of building the IoT solutions, and thereafter how the communication flows in your cloud environment. Thereafter, what this secure element is, and what is the role of this secure element and the crypto element. So this is a synonymous word actually, crypto element and secure element. So this is how the role of this secure element is into your complete of a project life cycle. And then we have this secure element. So we are going to talk about the leading industry secure element from the Microchip. So all so this is the most of the used. This is ATECC608A. So this is what we are going to talk about. And then we have this hands-on on the SAM IoT board and the Google Core IoT related to the implementation of secure element. So this is our today. So just moving forward, I'm just changing the way of camera so that you can have the view of the board. So this is our SAM IoT development board, which has the secure element, and this will be used for the practical purpose. So just starting with the session. So whenever we are going to design the IoT solutions, so what are the key elements, what are the key challenges that you face, which I had talked, is that the first and the foremost thing is that the device which you have, that's a physical device, how it could be connected securely to your cloud environment. Because you as a designer or the deployment engineer of this device have deployed your device at the customer location. Now it is at the mercy of the customer that how secure he keeps your device. And maybe many of the times the devices are kept in a public open environment, like the public cameras, public hotspot stations, thereafter the weather station. So these are the public places where one can easily access it. And if one accesses that device physically, and he is able to capture the secured communication that is going through that device to your cloud, and if you have not implemented any measures of the protection of the things, so he can easily tap your cloud communication data, and he can barge into your cloud network and can disturb all of the communication that is going through your cloud. So this could be the possible if you have not implemented any kind of a security measures. You have just taken a microcontroller, you are building an IoT project, you take any of the SoC which is available in the market, and your most common is like, I take the name, the ESPs and this Arduinos, thereafter the Node-RED, all such kind of SoCs are there. So there is not available such kind of this secure element features. So you have just the provisionings and the ID and password mechanisms in that, and with the help of them, with the help of that platform, if you have just implemented your project and put the thing in any of the public place, one can easily tap your device and just break the passwords and the ID. It is possible, and can barge into your cloud network. So your security becomes very vulnerable in that situation. So whenever we are building any kind of the IoT solution, we have to think from the point that if your hardware gets captured by any of the third party who is intentionally to harm your network, so he should not first he should not be able to get the data from your device, any of the kind. And even if he is able to get the data, that attack should remain limited to that device only. It should not be going onto the other devices. So like we have the cloud network over here, multiple of devices are connected to this cloud network. Even if in the worst of the scenario, this device has got captured, this device, the data he is able to recover from this device related to the secured communication. So this attack should remain limited to this device only, and all of these will remain in the seamless secured communication. So this is what we have to ensure, that at max only this device, and it should not go to the other of them. So this is what the challenges that we have is the secure device communication. The second thing comes related to the scaling. So in the cloud environment, it is not only a one vendor development. So you are deploying some solution for your customer, and maybe you the single Google Core IoT cloud is being used, so GCP is used, and you are deploying the solution for maybe for the monitoring of the power resources. So we have the various of the power resources and the monitoring solution you have designed for it, and that monitoring solution is connected to your Google Cloud. Now, you have deployed 100 of such monitoring devices, and it is working fine. And that was and these monitoring devices are for the power equipments of the lighting and the fan applications. Tomorrow, the client wants to monitor the kitchen equipments also, like this is a hotel client, and tomorrow he wants to monitor the kitchen equipments also. So you have the gateway available. Through this gateway, you have connected to your GCP, and the kitchen equipment which is there, it will also be connecting to this GCP only. The seamless communication, it should happen. And this might be from the third party. So the kitchen equipment monitor is from the third party. So now it is on your design, your design, because you have this is your all the designs are of yours. Now the third party has entered into this design for the information communication exchange. So if the third party comes into your network, so your system should remain so scalable that any of the third party vendor can't barge into your secured environment and can steal the data, neither from the software side nor from the hardware side. So this is what the scaling things is considered, and we have talked about this in the industrial IoT sector. And then we have the data analytics. So the use of this data analytics comes from these actionable insights. So based on the data that is coming through the devices, we take the different of the actions, like if the sensor is sensing the daylight, so it can turn off the lights in the lobby or in such places. So there are the different, maybe the temperature could be control of the air conditioning devices. So whatever the data that we are that is coming through the device, so the actionable insights should be controlled by those data from the device itself. The device should not be spoofed. So we have the sensor devices connected, and that sensor devices are sending the data to your cloud environment. And from the cloud, we are generating the commands to control the light. And so the GCP environment should identify that this is the sensor which is part of your network, and this sensor is not compromised. This sensor data is not spoofed. It might be possible that it is the day and someone wants to turn off your lights so that he can do some hanky panky. So maybe he can just spoof this sensor. He can put his own device, spoof this sensor into his own device, put the identity of this sensor into his own device. And through this, if he has compromised it, if he has compromised with your keys, so he can just connect to this cloud and can send the wrong data to the cloud, and based on which your light can be turned off. So even the right thing is that it is day and the light should be turned off. The spoofed sensor can send the non-static data and the wrong data, and light could be turned on. So it is possible. And so that's why the secured, so this three things, so this actionable insights data come from your secure device communication actually. So these three concerns remain always whenever you are designing the IoT solution. And while we are implementing the IoT security architecture, we have to consider about all of these three things always. So this is how this in this cloud environment, the data remains going from or there. And the three of the main stages that we call. So this is our device side that we remain. This is our local side. Thereafter, this is the thing that happens in cloud environment. And this is with the help of the IoT core. So like we are using the Google maybe for our hands-on today. So this is the Google IoT core. Same way we have the Azure IoT. We have we have the AWS IoT. So every of the cloud environment have their own IoT core through which your device is getting connected. And this IoT core is responsible for configuring your devices for the provisioning purposes, for giving allocations of the resources. And the device is kept sending the data to your IoT core, which is used for the purpose of later analytics. And then at this IoT core level, we have the multiple of sub-elements which relates to the data flow. So it is the functions, thereafter the topics. So maybe if you are aware of the MQTT standards. So you maybe here, maybe you have heard of about the pub subtopics. So publishers and the subscribers are there in the cloud environment, MQTT. So once you are accessing these things, so everything is in the cloud environment, MQTT protocol that accesses the pub subtopics, and it is working through that. So you can learn more about the MQTT and then can understand the pub subtopics. And then we have this data storage. So we have this query tables running, and related to the Google, we have the Firebase running. And then we have the ML methods also. So IoT is not only used for just controlling and the publications of the data, but with the help of the IoT, now you can implement the machine learning algorithms and can train your devices. So everything is available in the virtual format into this cloud. And with the help of this, the devices are getting configured, and the data, whatever is coming, that is used for the generations of the analytics. So actually, we are doing two things with the help of the cloud. First, we are always remain concerned about our data. So how the data will come, that data will remain secured, and the data should be enough meaningful. So the meaningful data you get for the analysis purpose. So the first thing is this. And second thing is that how do you manage your resources? So this is related to your functions of the cloud functions and the cloud data flow it comes. So this is the cloud environment that's how we operate on. And once we are talking, so we have to also see that how this communication flows into our cloud environment. So as I have talked about, so we have this devices and the cloud environment, and output of this comes through your analytics. So related to the communication, it is the device and the device manager inside your cloud. That's what is the main actors. So whenever from the previous of the session, if you remember, so we have this public key and the private key both. So private key remains with your device, and the public keys are there on the public environment. And whenever we have to authenticate the things, so both of the key pair are used, and it is the exchange of key happens. The public key and private key exchange happens, and then we do the communication. And in case of this cloud environment, we have this JSON web tokens. So JWTs are always created for the device signing and for the authentication purpose. So whenever the flow of communication happens, so it is the from the two of the sides, the device side and the device manager side, the communication happens related to the exchange of the public keys and the private key pair. And that relates to the device ID. So every device is having the unique device ID that is on the hardware encoded also it is possible. And for that, each of the physical device, we have a virtual device also available on the cloud. So whenever the data is sent from your physical device, that the virtual device on your cloud captures that data point and displays you, or should send the things in the analytics send the things for the analytics purpose. So between the device and device manager, we have the provisioning resources. So this provisioning resources is actually the a virtual thing which allocates and makes the exchange of the keys between the cloud and the device thing. So the provisioner creates your key pair and creates it and give it to the device manager. So every of the public key is associated with the device ID, and then it is given to the device manager. The device manager is saving that device associated. So it saves the whatever the device ID and the public key is available. So it saves in itself. And then this key pair is used for the purpose of JWT verification. So whenever the device has to communicate with the device manager, it sends a JWT token. And this JWT token is having the device ID and the JWT token having the device ID. This method is the connect method, and this is having the device ID, and JWT token has the request for the connection, which is signed with the private key of it. So every device has the private key that is signed with the private key that goes to the MQTT broker. So for the request connections, and through the MQTT broker, it goes to your device manager. And here this device manager has the device ID and the public key. So it knows, this device manager knows that what is the public key, what is the device ID, which is requested, and the private key for it. So with all these three informations, the private key has come through this JWT token. So with all these three informations, it verifies that whether the right device is requesting for the connection or not. If the right device, if all of the key pairs are matching, then only the device manager allocates the resources and the device gets connected to your broker. So this is how the flow of a secured communication happens over your network. But there is one more thing, is that we have to store the private keys and we have to assign the JWT tokens. So how we can keep the things secure? That's what the most thing is. And whenever we have to keep the things secure, so in that condition, the role of this secure element or crypto element comes in. So this is here, this crypto element is. So whatever, so all of the things that you can see is the same one. The same information flow is there. But whenever you store the private keys and the device IDs and the things, so that it won't be accessed by anyone, because if I'm talking about the device over here, so this device is made up with a microcontroller or some sensors or maybe some other network elements. So if we are storing all these private keys and our secure element features into the microcontroller and in some flash or SRAM, so that could be easily compromised, because that could be easily hackable. But if we have some kind of a feature, extra feature, which is also a hardware enabled, it is not a software enabled, it is a hardware enabled. So, and that is there with our device, which can store all these things, which can store our key pairs, which can store our device IDs, which can store our session keys, everything if it stores. So then it is the more of a secured environment that we can have, because this thing is separate from our device and that is there on the device PCB, but it is not able to be compromised. This thing could not be compromised because this is not stored in the flash or the SRAMs. So this device which we are attaching with our device, this element, actually this is not the device, this is the element. So this is what we are attaching with our device for the secured private public key storage and the information exchange. So any of the information that device exchanges over the network, that is signed with this with the credentials of this element, and then it is transferred, then the communication is transferred over the network, the cloud network. So this is what we are introducing, is the crypto element. So how do we generate the keys and store it over here? So all these things are there, the agenda of this today. And how does this, what are the protocols, what are the secure protocols through which this device is communicating to this element is communicating to your device? So that's what is also the agenda. So this is the crypto element. Actually, this is a hardware element which stores the keys and does all the authentications. So what this gives, so whenever we are talking about this crypto element or secure authentications, so we give the assurance in terms of the confidentiality. So sniffing is not possible. So your secure things are there on the on this secure element, which is not to be broken. So then that's how this data sniffing from your device is not possible in that case. So even if the security is barged, the physical security is barged of your device, one cannot access your private keys. And if he is not able to access the private keys of your device, so he cannot create the JWT tokens, which is required for the private key signed. So whenever we are signed, whenever we are sending, if we are spoofing your device, like someone has barged the security of this device, he has made a similar kind of a device and with the malicious codes, and he's sending the JWT token. But because that he doesn't have the access to your secure element, so what will happen, that he will not be able to create the authenticated JWT, because every secure element which is manufactured by the company has a different of a key, and that is provisioned at the manufacturing time. So that happens in a very secure environment. So every 2IC is a different, and none of them is identical, so that this kind of a spoofing is not possible at that end, until and unless this thing is completely removed from your PCB and then put onto the another one. But that's again kind of a typicality, in the sense that the physical security layer gets broken up in that case, and the communication doesn't happen. We have those methods also for the pairing. So that's why this JWT is not been assigned, not been signed by this secure element for a spoofed device, and it cannot connect to the cloud. So that's how this confidentiality that we are having available, and then the integrity. So that data could not be modified, because until and unless the JWT token is not assigned, so any kind of modifications are not possible, because the keys are not available. And once the non-repudiation, so whenever we have this secure element connected with our device, so the communication is dependent on this secure element. The cloud environment is actually identifying your private keys. JWT is signed with your private keys, which is connected with your, which is there inside your secure element. And this secure element is connected to your device. So cloud environment doesn't identify your device, but actually it identifies this secure element. So that's why if the secure element is there on your PCB, so the cloning of this device is not possible, and it is the it is verified that this information has come from the well-known sources. And if any of the data which is coming from the wrong of the source, which doesn't have the verified JWT signups, so that could be easily recognized. So this assurance that we get, and this is the key element for your security, is that we should be related our data. All these 4 things should be there, and that's what we get with the help of this secure element or the crypto element. Now, some of the times the question come into your mind that how if we implement this thing in the software means. So if you are implementing this thing in the software, so then we don't have to implement the PCB things, or we don't have to implement the hardware. We can save the costs also. But actually that is not possible, because whenever we are implementing this thing from the software means, so we can't isolate the price from the users. That's what one bigger concern is. And because that private keys will be there in your software, so that could be accessible and modified. Thereafter, it is possible to manipulate the keys, because it is there in your software, it is attached in your software. And if any of the wrong manufacturing practice or any of the wrong service person has come into your network, so he can easily manipulate your private key and can barge into the system. And thereafter, the microcontrollers are also not designed to keep these informations, because microcontrollers are the flash memories, and in the 32-bit environment we have the SRAM, where we can store such kind of informations. but all of those two, the flash and the SRAM, both can be easily accessible. And in case of 32-bit environments like ARM controllers, which is majorly used for the IoT implementations. So we have the external memories also connected where we store the program parts. So they remain connected through the SPI interface. So that is again the memory is extra, which is outside of your core. So because the ARM is the only the core, and thereafter we have the housings for the complete of the microcontroller. So that could be easily, those memories could be easily compromised, and that's why the microcontrollers are not designed for hosting such kind of a data. So that's why this we are not able to provide, and it is not a good idea to provide the these keys into the software level, and it is a hardware implementation in terms of this chipsets, the elements we are doing. So once we are implementing this thing in the hardware, so what are the different of the architectures that is been followed, and which one is a better one actually also? So there are the four of types of architectures are followed related to the secure element. The first of the architecture, which is a very odd one actually, but it is there. And this is having the very high-end CPUs are having such kind of a things where the multi-core, the dual core, or even more than that, the multi-core features are there in the CPU itself, in your core itself. So the crypto element. So if I have made you clear that crypto element or this hardware is a kind of which the secure element I'm talking about. So this is this secure element which I'm talking about. This is a kind of a hardware which is used for the purpose of storing of your secured keys, the public keys, private keys, and thereafter the secured sessions, and will give the authentications for your JWTs. So this is the job of this hardware layer is. And so how this hardware layer is implemented. So one of the architecture is where we implement this hardware layer into the core of your MCU itself. So maybe you have the multi-core MCU, and in one of the core, this crypto processor is attached with. It is possible, and there the connectivity, the radio is also there, the flash is also there, the RTOS is also there. Everything is there in your multi-core MCU. But this is a very typical case. It is a very costlier affair and doesn't remain suitable for the generic device designs. So that's why it doesn't remain. It doesn't remain a very good choice for the generic of IoT things design, IoT products design, but very high-end products could be designed over here. Like SAML is the device which is having such kind of a feature. Then the next of the architecture which is followed is having the MCU. MCU having the core is having the that memory, and that the secure, there is some secure area for the secured informations keeping, like for the public key, private key pairs. Everything is there in the secured area. And then we have the device ID and the crypto unit, crypto processor separately from your core. So this is within the complete of a one microcontroller, and where we have the crypto unit separate. But because this secured area is there on your microcontroller, and microcontroller are not designed to keep the code of securities. So that's why this thing can be, this secured area can be compromised with the help of the micro probings and maybe the hardware layer of the attacks. So and then your key will be easily available to the others for the usage. So that's why this thing is also less use. Thereafter, we have the MCU plus cryptography unit, and then this thing is like we have the SRAMs, where we are having the PUFs, sorry, that is for the firmware layers. And then we have the crypto unit separate. So some ST microelectronics microcontrollers are having this kind of a feature where the secure boot and the secure firmware update is provided through this feature, where the crypto unit remains separate and the SRAMs and PUFs are there on your MCU. And this cryptographic unit is like this Maxim IC has such kind of a crypto units, which can be there with your, which can be included with your MCU. And this MCU is here, the keys are actually software dependent. Here in this secured area also the keys are software dependent. In this MCU unit also the keys are the software dependent, and only the crypto processor is a separate one. And then it comes the secure element. So which is the most used in the industry is the where we have the microcontroller working separate. We don't have any of the secure things into the flash memory or in the SRAM. All the secure data there on your secure element, the crypto element. And whenever the data has to be sent from the MCU to the radio unit, so MCU sends, so we have this WinC controller, that is the radio controller for the communication of over the Wi-Fi. So whenever this data has to be sent through the WinC controller to the cloud, so this will be signed by this secure element. So the JWT tokens will be signed by this secure element, and we have the every of information stored in this hardware thing. And that is a unique. So if every IC that is manufactured is a unique in that case. And whenever you need also, like you are making some products and you need this secure element, so you have to contact to the company and give the ranges, and the company will assign the keys to your each of the device through the secured layer and will ship it to you. So that remains unique for yourself. So this is the secure element that is most implemented. And the company there are the different of the companies have the secure element, but most of used secure element is the Microchip secure element in the industry, and that gets connected with any of the semiconductor. It is not only for the Microchip controllers, but also with the other ST, Renaissance or NXP, the Samsung, all other microcontrollers can be connected with this crypto element, and irrespective of the number of bits. So even 8-bit devices can also be connected. Even if you are designing the ESP based project, like many of you are designing the ESP and Arduino based projects also for the hobby applications. So even the ESP and Arduino based microcontrollers which are not safe for the working, they can have this crypto element attached, and you can make your project secure. So that's what the role of any crypto element remains for the giving the security. It is in the hardware layer, it is there on your PCB, but it gives the complete of the communication up to your cloud level of a communication. So this crypto this crypto element, or we call it this crypto authentication companion. So this is designed to securely store your keys for the lifetime of the connected device. Till the time the device is connected, this is keeping all the data. So it is a tamper. So it is having the unique of a serial number, as I was talking about. It has the counters for the number of connections, and they are the random number generator. So whenever we are implementing the cryptography, so RNGs are having the very important of a role. So RNG is there inside it. And whenever the authentication happens between your microcontroller and this crypto element, so RNG is the first thing that takes care of for the secure communication. And it has all of the cryptography engines like your AES, SHA, ECC, the digital signatures, Diffie-Hellman algorithm. So everything is there inside it. And we have some secured EEPROM location also. So we have to store the keys, and for that purpose, this secured EEPROM is there, which is storing all the things, and it is not accessible outside. So only this secure element can access this secured EEPROM area. So from any of the external means, you can't access it. And then we have the multiple serial IO options like the SPI or I2C or single wire protocols are there. So through which it gets connected to your microcontroller and does the information exchange related to the signing. So now you may have a question that if it is getting connected through the microcontroller through some bus, so one can tap the bus and can barge the information. So actually the keys are never been sent. it is the signing of the tokens are done. So whenever the signing of the tokens are done, so tokens are sent to this secure element first. Before sending it to the cloud, the tokens are sent to this secure element from the microcontroller. Then the signing of the tokens are done, and those tokens are traveling through the network, not the keys there. So keys are generated by the device, and all the cryptographic algorithms are executed inside your tamper-proof hardware boundary. And that's how we are strictly isolating our keys from the software. So that's the hardware layer of a security that we are providing with the help of this cryptography layers. So if you want to know more about this, so we have a link, and I just share into your chat window also. So maybe if you want to read more about that, what this cryptography element is. So here this link goes, and this is. So there are the, right now I'm showing you about the ATECC608A. So if you are designing only the IoT based projects, the cloud communication projects, and your means of the communication is either the GSM or the Wi-Fi. So in that case, ATECC608A is good enough. But if you are having the LoRa based communications also in your implementation, then you will have to go to ATECC608B. So the two versions of it. So the ATECC608A is still in the production, but not suitable for the newer designs, because newer designs are generally having now the LoRa based communication. So 608A or 608B, anything, but everything is same. Only the 608B has the special LoRa communication security features. So you can see here that it is having all the algorithm support, and the single wire or I2C communication that we do over here, typically 2 milliamps. So it is a low power also and low voltage, only 2 volt to 3.3 volt is the standard working ranges. And it can work up to higher temperatures also. So this is the hardware feature you have. Thereafter, the I2C also happens at a very smaller of only one megahertz of a standard I2C interface. So that's how it is very tough to barge into this I2C network. And even if you want to make it more secure, so it is the single wire protocol if you implement. So then it becomes very secure communication. And it has the ECDSA. Thereafter, the serial numbers are generated up to 72-bit, and interface options like there I have told you a single wire and I2C. So this is a 8-pin IC, and it has the support for the symmetric algorithms and the asymmetric algorithms both. So, and we can store up to 16 keys or the certificates. So this is the some features. Maybe you can read more about it. I'm not going to give more time to this because we have to move further. So this is how it is functioning. So this is your ATECC hard crypto. So this is your ATECC engine, and this is having the crypto engine, and the private keys are it. Whenever the microcontroller has to communicate with it, so it will communicate I2C or a single wire communication. So first it is the RNG engine is used. So random numbers are generated, and if you want to know how the random number challenge is thrown, so just go to our previous cryptography primer session, and there I had talked about the random number thing. So the random number algorithms are working, how it is. So you can go to that previous session and can see about it. So microcontroller sends the random numbers, and that goes to the crypto engine. It sorts the random numbers, and based on that, the keys are attached onto the answers, and then it is sent to your controller. So the authentication comes from here. And if it matches, the results are matches for your random number generations. So it means the right of a communication is happening between the crypto engine and the a microcontroller, and then the information exchange related to the JWT tokens can happen over the this I2C bus or the single wire bus. So this crypto engine can be connected with any of the microcontroller, and no secure data communication. So it is only the information exchange related to the tokens are happening. Any of the secure information like the keys are not being transmitted through the bus. So it is so that's how the small of a communication network that we can see, and it is protected against the hardware attacks, any kind of the hardware attacks also, because this is the hardware and it has a secured layer in the casing of it. It has a secured layer, so not of you can do the micro probing or the fault injection attacks or the power cycling attacks. So in the hardware security session, if you will see that we had these discussions on the how the clock glitchings and the power cycling works on. And so these are the different kind of attacks that is possible on the hardware layer. So it can withstand all the kind of there is no effect of any such kind of attack happens onto this device. So that's how it is the each of our private key that is generated for the device that gets securely inside this ATECC608A, and it is not known to anybody because it is not accessible at all. And whatever the certificates that you generate for the communication, the root certificate. So whenever you are implementing the IoT security, so you have to generate the root certificates through the cloud. That's what we will be generating today. So those root certificates are also stored over here, and that also cannot be accessed by anyone, because we have the HSM module over here, the hardware security module over here, and that HSM module doesn't make it readable by the outside environment, these certificates. So whenever this ATECC communicates with the cloud and the microcontroller is in the middle, so how this communication happens, so you can see it over here. So the microcontroller has to communicate to the the cloud, but it doesn't directly communicate with the cloud. You can see here, it is first making the hashing the JWT token. So we have the hash algorithms, and those hash algorithms are used for the JSON Web Tokens hashing, and it is sent to the JWT. It is sent to the hardware layer of your ATECC. The JWT token is received by the ATECC. It stamps signature over it. The digital signature is stamped over it, and then it is sent back to the controller, which is so this controller, it comes to the controller, and then this JWT token becomes the ECDSA appended. So this ECDSA is appended by this ATECC. So the signed JWT token comes over the network, and then this JWT is sent to the cloud, and the cloud has the public key. So we are sending the private key signed JWT tokens from here, that is going to the network. The cloud has the public key of the device, and if the public key and private key match, so in that condition, the cloud will authenticate your device, and the information exchange can happen from your microcontroller to the cloud. So the initial authentication thing is done by the ATECC device, and thereafter it remains a secured communication between your controller to the cloud. So, and for this purpose, we have this crypto authentication libraries, and this library is implemented for this ATECC device itself. So whenever you are developing the programs related to the ATECC, this crypto authentication libraries are also implemented into it. So for the how do we implement this thing? So this ATECC is basically a hardware element, but whenever we have to use it, it will be used in conjunction with a microcontroller. So here is our SAM IoT board. So which is there in the video also you can see. So which is a connected board is the same SAM IoT development board. And you can see it over here. We have the radio controller AT-VNC1510. Then we have the ARM microcontroller, that is AT-SAMD21G18A. This is ARM Cortex M0. And then we have this secure element. So this is actually this chipset, which is for the purpose of ATECC608A, that is for the purpose of secure element configurations. And this is communicating to your controller. And this controller is communicating to the WinC for the purpose of radio communications. On this board, we have some of the other sensors and the LEDs and all the things for the purpose of user interfaces. And this is what we will be using for the, so this is a board which comes in a sandbox form and can communicate to the cloud directly. So this is the, you can see here, the I2C interface. So this is the schematic, one small schematic that I'm showing to you for the network communication. So this is your SAM microcontroller. This is our WinC, and here is the this ATECC. And if you can see this communication, the two-wire communication line is coming, and this is the I2C communication line coming, and this I2C communication line is coming throughout this. So this is the SCL and SDA. So two-wire communication is happening with this ATECC to the SAMD21 microcontroller on this development board. So this is the I2C protocol that we are using. So this board is coming, and I just show you that this board is authenticated right now, and the things are there inside it. So how this application, so I just open and show it to you. So this is the sandbox application, and it is already provisioned, and so we can see over here that it is already provisioned, and the device ID is this, and it is having the light and the temperature sensor right now. So the data that the light sensors and the temperature sensor over here. And if I just put if I put my finger, so you can see in the video that I have put the finger on the light sensor, and the light is dropping, you can see. So it is almost gone to 0. And then we have this temperatures also coming. And so this is the sandbox application. It is properly authenticated. And the firmware related to it is that I will show you. But before of that, we have the keys for this. So I show you the keys. So you can see here, we have the certificates over here, and these certificates are actually inside our, secure element, which is used for the authentication purpose. But if you design a certificate, if you have to download some certificate, how you can do it? So I just give you a small of introduction that how do we develop our own certificates for the purpose of authentication. And if you want to see this thing, so this is the application part is, and if you want to see the public key of it, so we can just, so it is here, I'm connecting it on my terminal using the font. So here is the so you can see here the public keys that we can see, because that is open to the network. But if you want to access the private keys, that won't be possible for you. So because private keys are there unique for that particular of a secure element, and that cannot be accessed outside. So now I am making a complete of a key pair on the cloud, and just see that how it happens. So for this purpose, you have to create a cloud account, like I have here the Google cloud platform I'm using, and you can use it either the Google or maybe the Azure, Amazon, AWS, any of the cloud platform you will use, you can use. And for that purpose, you have to, the keys are generated. Once you will create your device, so the keys are generated for this purpose. So I'm going to do it step by step, the generation of the keys for the secure communication purpose. So what we have to do, but with the help of the key generation, actually we have to communicate the data from our device to the cloud. And for the data communication, the MQTT protocol is used, and that MQTT protocol has the publishings and the subscriptions of the data. And the publishing or the subscription of the data happens over the topics. So MQTT topics are created, and based on which the data are communicated. So we have to create the keys, but before of that, we need to create the topics, so that the data is actually the more important part. So those topics will be associated with the devices, and for that devices, we will be creating the keys. So we start with the topic creation, and for that we have the pub sub is the product based on which the MQTT topics are created. So I just create some topic. How many of you are aware about the MQTT protocol? Or is it a completely new thing going for you? Have you worked with our MQTT protocol before? No? So here I'm creating a topic. So let me create a topic like something. Creating a topic, event 1. A topic in the name of event. I'm creating another topic in name of event 1. And as I have created this topic, so you can see here, my topic is created over here. So this is my topic is created in the name of event 1. And as I have created the topic, there is a one subscription is already been created, this event 1 sub, in the name of event 1 sub, you can see. So this is a default subscription is created, but we want to create one more subscription with it. So I'm going to the subscription, and I'm creating a subscription for it. So with the help of this subscription, actually we are accessing the data. So whatever the data that will be pushed onto your topic, with the help of this subscription, this data will be captured on. Like for an example, you have a light switch in your home, and that light switch will turn on the light, the LED light in your home. So the light switch, once we are working in the IoT environment, so the light switch doesn't directly gets connected with your bulb. Actually, it is the MQTT broker is in between. The light switch will publish the message of turning it on the MQTT broker on the topic of a light, and the bulb will be subscribed to the topic of light. And then if it sees the message as a on, then it will get turned on. If it sees the message as a off, it will remain turned off. So this is how it happens. And this is quite different from the normal HTTP REST API, where we have the direct of a communication happening between the devices, which is communicated, which is in a communication. So MQTT is both of the devices doesn't know each other in the MQTT communication, and it is not necessary to remain connected at the same of the time. So that's why this subscription and the publishing IDs are created. And I'm creating here this subscription ID in the name of example 1. and it has to be associated with a topic. That's the event one is the topic. I'm associating it, and I just create it. So you can see here we have the subscription topic connected in the created in the name of example one, and that is associated with our topic event one. Now, if I go to the topic event one, we have this subscriptions created. So we have this subscription is created, and right now any message is not there, but if we have the message, we can view it also. So right now we don't have any message. If we pull it also, you can see that there is a no message is found. But if we publish any message on this topic, then it is possible that we can have the message onto the subscription topic also. So here is the message that you can see, and I'm publishing some message. So I am publishing it on like so the message is published, and because it is subscribed, so example one is subscribing it. So if I go to the message, and if I pull it, you can see here that it has got updated with the message hello. So like this is the same thing. This is the implementation of this the MQTT public the publish and the subscribe methods. So whatever the message that you publish, that is subscribed by the subscription topics, and based on this message, the device status could be changed or the device status could be published. So this is the small example for your pops up. So this is what we have created the topic for us. Now I will have to create the devices and the keys related to it. And for that purpose, the devices are there in your IoT core registries. So I'm just creating the IoT, bringing the IoT core product. So there is a one registry already created. I'm creating another registry for your demonstration purpose. So here is the registry I'm creating as a demo one. And region I'm selecting is Asia. And the topics which I have used is the event one topic which I have selected. So that's what is. Right now, any of the other topics I have not created, and I don't want to include any of the logging features also, so that we can just save the memory on the cloud, and because cloud is a little costlier item. And the certificates we are not right now giving. Once we will be creating the device, that time the certificates will be assigned. So I just create the registry for it. So our registry is created in the name of a demo one, you can see, and the logging feature is disabled on it, and the topic which is associated. So the data which will be there on the topic of event one will be accessed by the device with the help of the keys which we will be creating. Right now, we don't have any of the certificates and the key. So for that thing to associate, we have to attach the service accounts, and the service accounts are there in the admin and admin feature of the Google IoT core. So here it comes the IAM, and inside this the service accounts are there, you can see. So we have to create some service account, for this. So I'm just creating a service account in name like demo1. And this is the demo1 is there. The descriptions are there. We just create the service account. And then we have to assign this service account with the pub sub. So here the pub sub is there, and we want to do the editing of the publisher and the subscriber. So both of the feature that we want to have. So that's why I have selected the role for the pub sub editor. And then just we create it. And it is done. So our device is created, and thereafter role is our service account is created, and our this is also the role related to it is also created. Now I need to create the device so that I can generate the keys for it. So IoT core comes. Demo one is our registry. Here is the devices. So we have to create a device. Right now, none of the device that you can see with this registry. We have another of the registry available. And if we go to the registry details, you can see, and the demo one is there. And then we have the another registry which has already been created in the name of a demo. And there, if I go, you can see the device is already there. There is a one device which is already there. So we can create, so this is kind of a grouping that you can see. So we have the multiple of the registries in the IoT core, and the multiple of the devices we can attach with the registries. So right now I have created a separate of a registry that is in the name of a demo one. So separate of a device grouping that I will assign. So in the same of the cloud account, actually for the multiple of the projects, we have to create the multiple of the registries, and the multiple grouping of the devices could be associated with it. So the devices, it comes, and right now we don't have a device. So I just create a device over here, and device one, I give it, just create it. So we can see over here the configurations, states, and authentications are there. So here is the thing where you have to attach the public key for your device. So right now you don't know the public key, what it is. And but before of that, there is one mistake. So created a device over here. I have to give the public key for our things. And for that purpose, we have to add the public key, and we can give up to 3 public keys. So here are the different of the algorithm. They are the different of the formats. And you can see here the ES256 is one. And here is our device is connected, and I have got this public key as here. If you want to give it a name, the date, so you can also give the date of the expirations. Otherwise, this will remain valid till the life of your project. So this public key is got added to your device. And once this device will get connected, so this public key and private key pair will be used for the authentication of your devices. So this is how we attach our public keys to the communication. And then we have this complete of a program, which is there. And so this is the firmware for it. Right now we don't have the time for it, but yes, this everything is covered in our programs. So this is the sandbox application programs, and you can see over here we have the certificates, the credentials, storages, things, and then we have this MQTT things. So through this, the secured exchange of a communication happens. So this is the complete of a program, and this thing is generated through the MHC framework. So for the working with the SAM microcontroller, the MHC framework is there, and through this MHC framework, we do the configurations of the items. Like here you can see here the ATECC is there. The crypto authentication library is enabled for it, and the I2C interface we are using for it, and all the configurations. So related to this, all configurations are done, and the code generation is there, and that gets attached to your program, and keys are there. And once the communication happens, so these keys are getting utilized for the communication purpose. The private keys always remain inside your ATECC, and the public keys are used for the authentication purpose. So this is how the keys are used for the purpose of information exchange and the sending the data from the one location to the another of the locations. Now you can download the keys also, but that's a different step is there. So you can download the keys in the here and can attach in your this can attach into your project. So here if I have shown you, so that's a different process is there, and I'm not able to cover right now. The time is very limited. So this is how the keys are downloaded in the JSON format. You can see. So we have this. You can see here the private keys are not there, but public keys are there. Public keys can be downloaded. So this is the JSON format that comes, and then we have this every of the informations which is a public. So your client email, the client ID. So this is the format of your key certificate. So you have the client ID which is given from the cloud. This is maximum of a 72-bit. It could be. Thereafter your authorization URLs, the token URL, the certificate. So X509 is the certificate that is being used for the cloud communication. So both all the informations are there, and then it is it is used for the. So this is the private key actually for the cloud side. This is not from your secured element side. So this private key is from the cloud side, and the secure element cloud is private key is not readable, but this private key gets exchanged to the secure element private public key, and then the complete of a key pair is matched. So if you remember that whenever we are making the key pairs, so if two of the devices are communicating, so the public key of one device and the private key of another device is used for the communication, and then the secure exchange starts happening. So private key from the cloud side we have, and the private key from our secure element is there inside this hardware, and then we are then we do the information exchange between the devices. So if you have to read more about that, how this thing happens, so you can go to the cloud environment and can read about it more. I'm pasting you the links. And to know more about the trust platform, so here this link is. So you can go through these two links and can learn more about the how the Google Core IoT is used for this purpose and the trust platforms are working. So this was the session today, and hope you have joined the Edmodo link through the Edmodo link also, so that you can access these things later on. If you have joined recently, that if you have means during the sessions once I have started with after, so I'm sharing the again the Edmodo link so that you can have the access of it. So through this, you can join this community and can remain active onto this. But I have a sincere request that stay active. It is not only just use it for the material viewing purpose, but stay active on this and keep information exchange and the communication going on. So that is the session today. Hope you have liked it. Any of the queries, if you have, I'm waiting for you. Any of the queries, you can just put it into your chat window, or maybe you can unmute yourself.